Okay, well, you've already watched the first video, and the first video was over the front side of the review sheet. So it was over problems 1 through 11, and it was over problems 12 through 30. What we're going to do now is we're going to look at the back of the review. So on the back of the review, in the matching section, a couple of things you had to remember about your calculator when you get to this section is you need to go to mode in your calculator, and we're going to go back to radians, and then you need to arrow over to polar. And then you're going to go to your format, which is second, zoom, and you're going to make sure that your polar graphing coordinate system is on. And you can actually leave this on, and you can also leave it in polar the whole time you're doing the test. You're just going to have to make sure that when you're doing angles on the front part of the review that you're in degrees, but when you go to this graphing part that you're in radians. Unless they tell you to give them the angle in radians. The front part of the review was just about all in degrees, but again, this back section, this matching section, go back to radians. And then we're going to go to our window. I'm going to go from 0 to 2 pi, and someone today in class said, hey, every time I type in 2 pi, it goes away. It's not going away. The calculator just said 3.14 times 2, which is 6.28, blah, blah, blah. Our step is going to be pi divided by 24, and again, your calculator will do it for you. You can make your max and min be whatever you want. I usually start at -10 to +10, and I leave my scale to go by 1. Again, you don't have to do that. That's just how I usually start off. Okay, so from there, we're going to go to our y equals, and now they all say r equals, and all of these say r equals, so we just simply type them in the calculator. So I type in 3 cosine. It says theta. Your theta button is where your X button is. So you just hit the X button, and when you hit that, theta pops up, close parentheses, and I go hit graph, and I see that I have a circle going to the right. So if I look over here, I need a circle going to the right. That's letter D. So again, it's not that big a deal. You're just typing it in your calculator as you go. The next one says that I need 3 sine theta. So I go type in the theta again, I hit graph, and now I have a circle above 0, 0, and that is letter G. And you're going to do the same thing for 33 through 38. So if you have a graphing calculator, go type those in real quick, pause the video, and then come back and check your answers. If you don't have a calculator, then you're sitting here watching me do these. So we've got 1 plus 2 sine theta, and I hit graph. And it looks like I have a limacon with a loop, which is letter E. And as you use them, you can kind of mark, I would mark them off so that you don't have to worry about those anymore. Okay, then we have 2 plus 2 cosine, 2 plus 2 cosine. And this is the cardioid, the one that looks like the heart, and it's going to the right, so that's letter B. Cross that one off now. Then we have 2 cosine 4 theta, 2 cosine 4 theta. And this is where we have the petals, the rows with the petals. Notice on these petals that I have two petals. I have a petal on the X, and I have petals on the Y. So when I'm looking at them, A and H look really similar. The H has the one with the petals that are actually on the axis. So you gotta be careful when you're looking at your graphs. Okay, the next one is 2 cosine 3 theta. And this is where I have a petal on the X and the other two are not. So if I look at what I got here, that's letter C. And we got 2 sine 4 theta. This is my other rows, but this time you'll notice that my petals are diagonal to the X and Y. They're slanted, they're like 45 degrees. They never actually touch the X and Y, which happens to be A. Okay, 38, we have 2 sine 3 theta. And this time my petal's on the Y, which is letter F. And then we have 39. Now before you can enter 39 in your calculator, you'll notice these all say R. None of them say R squared. So you have to take the square root of the right-hand side. You need to remember that anytime you take the square root and you're graphing, unless you restrict the domain, that you're always going to put a plus or minus here. And you're going to let the calculator go do the work. You don't actually have to go take the square root or anything. So I'm going to have the square root of 4 cosine theta, and then I'm going to have negative square root of 4 cosine theta. So I did the positive and the bottom, and the negative, plus or minus. And then I go hit graph, and it connects it, and can I get a figure 8? This was the lemon skate, that's how I said it, and that's letter I. So when you're doing this section in your calculator one more time, you need to remember to go to mode, and in mode you need to be in radians, and you also need to be polar, and then you also need to go to format, which is your second zoom, and you need to pick the one that says polar. Okay? Alright, down here on 40 through 46, we did some of this on the front. I'm just repeating it again because you're going to see it on your test, and I added these two problems called unit vector to make sure we go over how to do that because I did not put those on the front. So when you're adding vectors v and w, remember to add the i's with the i's and the j's with the j's. So I have negative 3i plus 2i. Well, negative 3i plus 2i is negative 1i, or just negative I. And then I've got negative 4j and positive 4j, which is 0j's. So your answer is just negative I. 41 wants me to subtract the w minus the v. So I'm actually going to go write this one out because it's one that y'all tend to miss. So 2i plus 4j minus negative 3i minus 4j. So term to term, 2i minus a negative. Well, 2 minus a negative is really a positive, so that's 5i. And then we have 4 minus a negative 4. Well, minus a negative, again, is going to change to a positive. So a lot of y'all are going to fall for this, and you're going to think it's 0. But remember, negative negative changes to a plus, so that's plus 8j. And if you forget, you can add the coefficients in your calculator. So just add the 2 minus negative 3, and you'll see it pops out 5. And then you're going to have 4 minus a negative 4, and you'll see it pops out 8. Don't add the i's and j's in there, just the coefficients of vectors. 42 wants me to take my w vector and multiply everything by 2. So you're going to say 2 times 2i plus 4j. And you're just going to distribute. So you get 2 times 2 is 4, so you have 4i. 2 times 4 is 8, so we have 8j. Okay, number 43, it asked me to do these little bar things, so we need to go over what that means again. When you see those double bars, it means to find the magnitude. And if your vector is written in the form of ai and then the b with the j, then this is the formula that we're going to use, the square root of a squared plus b squared. So I'm going to have the square root of negative 3 squared plus negative 4 squared. Y'all, a lot of y'all mess this up in class. Remember, anytime you square a negative, it's going to be a positive. So if you're using your calculator, I know some of y'all do, some of y'all go type it in like this. You get a negative 9, and out of habit, you think the calculator is always right, you think you're wrong, and you write down negative 9. When you type it in your calculator, if you don't put the negative in parentheses, the calculator will give you a negative. Notice it's in parentheses. So it's not negative 9, it's positive 9. And the same thing here with negative 4. Remember to put it in parentheses when you square it. So we have 9 plus 16. 9 plus 16 is 25, and the square root of 25 is 5. All right, 44, it has v dot w, and that's asking you to find the dot product. To find the dot product, the formula was you multiply the a's, and then you're going to multiply the b's, and then you're going to add them together. So I'm going to multiply both a's, multiply both b's, and I'm going to add my answers together. So that goes to that one. So my a's are negative 3 and 2. So negative 3 times 2 plus, that's a times sign. My b's are negative 4 and positive 4. So I multiply negative 3 times 2. I'm going to come over here. I get negative 6 plus negative 4 times 4, and I get negative 16. Then I add those together. Negative 6 plus negative 16 equals negative 22. The dot product is negative 22. All right, so we haven't done one like 45 yet, so that's why I made sure to put this on the back. On 45, they're asking you to find the unit vector. When they ask you to find the unit vector, you need to find, I'm trying to see if it's the formula for the unit vector is the vector divided by the magnitude of the vector. That's all you have to do. So the vector v, I'm going to have negative 3i minus 4j divided by the magnitude of v. And remember, to find the magnitude, you do your a squared plus your b squared. It's these same two numbers, and then you have to remember to square root it. So I have negative 3i minus 4j over, well, we actually just did this problem right here. So I know that when I find the magnitude of v, negative 3 squared is 9, negative 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. All I have to do now is divide the terms, or I could leave it like this. So this is one way to write it, or you could write negative 3i over 5 minus 4j over 5. Both of these answers are correct. They're both fine. 46, you're going to do the exact same thing we just did. The first thing you're going to do is write down vector w. So 2i plus 4j divided by, we have to find the magnitude of this. So it's your a squared plus your b squared, and then square root it. So 2 squared plus 4 squared. Notice I didn't put parentheses this time like I did over here because they're both positive, so I don't really need to. So I have 2i plus 4j over 2 squared is 4, 4 squared is 16, and 16 plus 4 is 20. Then I have to remember to square root it. Square root of 20 can be simplified into 2i plus 4j, and that can be simplified into 2 square roots of 5. From here, you would separate it into two separate fractions, and dun dun dun, trashy math, you fix your trashy math. You're not going to have one as hard as this on your test, but you will have one very similar to 45. So if you're good with 45, then don't stress about the dun dun dun, trashy math. That's not a big deal. Okay, so let's flip over and look at the back. The other side. So there will be a problem on your test, and it will be multiple choice format, where you're going to have some vectors drawn, and then they're going to ask you to pick the graph that correctly represents 2v, v plus w, and v minus w. So I want to make sure we practice that. If they ask you to do 2v, what you need to do is you need to have a vector that's going the same direction as v, but it needs to be twice as long. Well, let's go figure out how long v is. V is 1, 2, 3, 4. It's 5 squares long. So I have to go 5 times 2. I have to go 10 squares to the right. So let's see how many squares I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, isn't that nice? So you can start your vector anywhere you want on the left-hand side, but I do need to start all the way to the left because it only goes 10 to the right. So that represents 2v. That's all you had to do. 48 wants me to add v to w. So when you're adding two vectors, you have to remember to graph them head to tail, but your resultant will be drawn head to head. All right, so if I'm going to add v to w, the first thing I need to notice is that v is going to go to the right 5, and then w goes right 2 and up 1, 2, 3, 4. So I have to have room to do that. So you got to kind of lay your picture out here. I'm going to go 5. So 1, 2, 3, 4, 5. That's v. When I go add w, I have to start the head right here at this tail. And again, it goes 1, 2 to the right, and it goes up 1, 2, wait, it goes up, it's hard for me to see. It goes 1, 2, 3, 4. So from here, I'm going to go right 2, 1, 2, up 4, 1, 2, 3, 4. Right there, head to tail. Okay, so that's the addition part. Now I have to go draw the resultant. I'm going to draw my resultant in my red. It has to go head to head and tail to tail. This represents V plus W, just the red part. So on your test, they might not show you this part that I have in black. They might just show you a vector that's just this slanted vector, and you would look at that and look at your other multiple choice to make sure it's going the right direction. Like mine might have one like this going up, and they might have one going down. And obviously, if you did it on the scratch paper, you would see that you want the one that goes up and to the right. Okay, so we're going to do one more. We're going to do V minus W. So because I'm going to subtract W, it just means it's going to be the same magnitude. So it's still going to go horizontal 2 and vertical 5, but I'm going to go in the opposite direction. So for that reason, I want to start my V at top. It's still going to be only 5 long. So 1, 2, 3, 4, 5. It's still head to tail, but instead of going right 2, up 4, I'm going to go left 2, 1, 2, down 4. 1, 2, 3, 4. Still head to tail. That part doesn't change. That's V. That's negative W. And you're still going to connect your resultant head to head, tail to tail. And you're going to label it V minus W. Again, on the test, you might just see the red part graphed. You're going to need to go to the side on your scratch paper, draw the problem, and notice that your vector is going southeast. So it's going down and to the right. There'll be several vectors drawn. You want to pick the one that's going down and to the right. Okay. 50 through 55 are all like problems that are on the front, but this time it's multiple choice style, so we can talk about that. So when you're doing this problem right here, it says give polar coordinates for the point 0, 3. If they want me to give polar, it means they must have given me the x and the y. The first step in doing these is always to graph it. So anytime they give you x, y, and ask you to change it to polar, you start by graphing. So if I was going to graph the point 0, 3, I would go right none and up 3. Well, I can look at that picture and I already tell, oh, that's 90 degrees on my unit circle and my radius is 3. When you write a polar coordinate, it's always r, comma, theta. Your radius, comma, your angle. My angle is 90, not 90, not 90, not 90. Oh, the only one that has 90 is B. 51. Give the polar coordinates for the point 2, 0. This time they want me to do it in radians. It's the same type of problem though. This is my x and this is my y. So I'm going to graph the point 2, 0, right? 2. And then I'm going to put a point right there. Okay. So that right there is 0 pi or 0 radians and my radius is 2. But none of my answers have 0 pi. I have a positive pi, a pi over 2, a negative pi over 2, and another positive pi. So first of all, positive pi over 2 would be up here. So that's not it. Can't be that one. Negative pi over 2 would be down here. So it can't be that one. Which must mean they're over here at pi. So I have to decide, is this point right here 2 towards pi or 2 away from pi? Well, it's 2 in the opposite direction, which must mean they're rewriting this with a negative radius. So the answer is A. So what you need to remember is if they give you a positive radius, you're going towards the angle. But if they give you a negative radius, you're going away. So because this says negative 2 pi, I would go to the pi. I go to the middle, which is now called the pole, and I go 2 away. 52. Express in rectangular form. So this time they gave it to me in polar. This is my r, and this is my theta. Notice it's in degrees, and they want me to find the rectangular form. Okay, so the formula for this is x equals r cosine theta, and y equals r sine theta. Even if you don't know your unit circle, you should be able to get this right. So we're going to make sure I'm in the right mode. Notice earlier when we were graphing, we changed it to radians, so I have to remember to go back and change it to degrees, and you're going to have to remember to do that during the test. Okay, so now I'm going to go do my radius of 2 square roots of 3. So 2 square roots of 3, arrow out, times cosine of 330 degrees. When I do that, I get the answer of 3. So my x has to be a positive 3. Not it, not it, not it. I'm done. Don't spend more time on it than that. You already know your x is 3. Everybody else says -3. They're not it. Okay, 53. It's the exact same thing, but this time expressed in polar form where theta is in radians. Oh, I'm sorry, this isn't the same thing. This is my x, this is my y, and they want me to solve for the polar. Okay, so that has a different formula. To find your r, and you're going to remember have these formulas on your test, it's x squared plus y squared, and then we're going to square root it. So I'm going to have r equals -1 squared is 1, negative square root of 3 squared is 3, 1 plus 3 is 4, and the square root of 4 is 2. So I need to have a radius of 2. This has a 2, this has a 2, that has a -2, and that has a +2. Okay, now I have to go find my theta. To find your theta, you're going to divide the y by the x. So negative square root of 3 divided by -1. Okay, well, I know that negative square root of 3 divided by -1 is square root of 3. I also know that anytime I'm doing tangents on my circle, the square root of 3's are at the pi over 3's. And I know that tangent is positive in this quadrant and this quadrant. So what I have to figure out is which quadrant was my original point in. Well, negative x and a negative y means I'm down here. And in quadrant 3, my numerators are always 1 more than the denominator. So that's 4 pi over 3. So I need 2 for my radius, and I need my angle to be 4 pi over 3, which is A. Okay, let's say on 54, express in rectangular form 4, 270. If I asked you to graph 4, 270 degrees, you would find 270 degrees, which is right here on my circle at the bottom, and I would go 4 towards it, 1, 2, 3, 4. So if I asked you with that ordered pair right there, you would hopefully tell me it's 0, -4. So I was able to do this one without using the formula. But you could have used the formula. We're going to use it. It's right here. Remember, we're in degree mode. So the formula says to find x, you're going to do r, which is 4, times cosine of theta, which is 270. And we find out that x is 0. Not 0, not 0, 0, 0. So I had two choices. Then I'm going to do my y formula. It says do r times sine of theta. So 4 times sine of 270. Oops, I did cosine again. Let me try that again. 4 times sine of 270. And we get -4. So that just verifies my answer is actually C. The last one says express in rectangular form 2, 200. It's the same type of problem. X equals 2 times cosine of 200 degrees. We're going to type that in our calculator. 2 times cosine of 200 degrees is -1.879. So -1.88. That looks like it's the only one. So I'm going to say that B is my answer. I'm going to go ahead and check the y one just to make sure. Y is r times sine theta. So r is 2. We're going to do sine of 200. And it's -0.68, which is, hey, that's exactly what that says. Okay, so we have gone over the entire review, front and back. If you have any questions, make sure you come to tutoring. Ask me questions in class. Good luck.